Please open your learning workbooks to page 134. We're going to continue section 2.8. This topic is evaluating functions. Let's begin with example 2. Given m of x equals 4x, n of x equals the absolute value of the difference x subtract 3, and p of x equals the rational expression whose numerator is 1 and whose denominator is the sum x plus 1. Find part A, m minus n of negative 2. Okay, so for the first time we're seeing a number here instead of a letter, but the idea is still the same. This just means take two functions, which are each being evaluated using the input negative 2, and subtract them. So this gives us m of negative 2 subtract n of negative 2. I would like to figure out what both of these are, and I'm going to do that in my side workspace. Let's start with m of negative 2. We know that m of x is equal to 4x. So that means m of negative 2 is equal to 4 times negative 2, which is negative 8. Using the same approach, n of x is equal to the absolute value of x subtract 3. Replacing each x with a negative 2 in parentheses, and then simplifying. These parentheses are unnecessary and can be dropped. They don't have a multiplier out front, a subtraction sign out front, or an exponent. Absolute value is a grouping symbol. We work inside first, then take the absolute value. So we now know that m of negative 2 equals negative 8, and n of negative 2 equals 5. All that's left to do is to subtract those two values. So we have the negative 8 subtract the 5. The answer is negative 13. Okay, let's find something else. Part B. Find p over n of 3. Once again, we see a number here instead of a letter, but the idea is exactly the same as what we learned previously. This means take my two functions, p and n, and divide them, where each one is being evaluated for the input 3. p of 3 divided by n of 3. Let's figure out what both of these are in our side workspace. p of x is equal to 1 over x plus 1. So p of 3 would be found by replacing all of the x's with a 3 in parentheses. These parentheses are unnecessary for the reasons stated previously. 3 plus 1 is 4, so we get p of 3 equals 1/4. Now we'll move on to n of 3. n of x is equal to the absolute value of x minus 3. So if I want to find what n of 3 is, I just have to replace all of my x's with 3. Okay, these parentheses are unnecessary for the reasons stated previously. So I have the absolute value of 3 subtract 3. Work inside the absolute value bars first. So this gives me the absolute value of 0, LOL, which equals 0. Okay, so now we know that P of 3 equals 1/4, and N of 3 equals 0. We can put both of those into this problem. We'll replace P of 3 with 1/4. We'll replace N of 3 with 0. And then we will evaluate. Division by 0 is undefined. And that is the end of this problem.